Okay, so now we're at lesson 5, which is laws of logarithm, and we're gonna get started. So it says here from the previous lessons 3 and 4, particularly lesson 4, that we saw in previous lesson that logarithms are necessary to solve exponential equations that can't be solved using the same base technique. So there are laws of logarithm that are found on a formula sheet, and we'll refer that. I referred to that earlier. This is going to be on your provincial exam formula sheet. So laws of logarithm. As with exponent, we have exponent laws. There are exponent laws, and we use when working with logarithms. So this is connected to the exponent laws that we've used before. So these laws are used to simplify logarithm expressions or to expand logarithm expressions. So the first one here is log of m times n base a. Now, if you focus on this one, it's m times n. What do we do when we multiply powers? We have the same base. We add them, right? That's why it says here log of m base a add log of n base a. So when you're multiplying powers, the same base, this is a power m with the base a, n with the base a, you add the exponents. What do we do when the power have the same base and then you're dividing them?
Subtract.
You're going to subtract. That's why there's a subtraction in between. And m to the n, what do you do to the power? It's basically multiply, right? Here's the other things that we also need to know. Log of a to the n for base a. So we're asking ourselves, and we saw that in a previous example, when you have what exponent do I need for a to get a to the n? Well, the answer is n. Does that make sense? And it says here, what exponent do I need to put a as so that to get 1 would be 0. The exponent would be 0. Anything to the base a exponent 0 is going to be 1. A log of a base a, it's 1. Right? So those ones are going to be helpful for us later on. Yeah. This one? This one? Yeah. So I'm going to rewrite this this is in a log form, logarithm, right? So if I go, this is your base and this is exponent, right? So a to the 0 is 1. So a would be this base, 0 is your exponent, and then 1 is the value. Yes? It's good. So now it says here, use the laws of logarithm to rewrite as a single logarithm. Because sometimes the expanded version, we need to write it as a single version, a single form. So how do we do that? Okay, what do we do here? 2 exponents are added together. So that means the power have to be multiplied, right? So if we were to write this as a single logarithm, it would be log of x times y with base 4. Okay, because if we multiply things together with power, we add the exponent, and these are the exponents. What about this part? How can we rewrite this so that it's one logarithm, single logarithm form. I see that this is being subtracted. It's going to be divide, right? So exponents are subtracted, so that means the power that have the same base have been divided. So log of x squared divided by y base 2. So these are I call all the time baby steps, and we can't take this for granted. Baby steps. Okay, now let's go to the next page. What do we see in here? I see two exponents that got added and then subtracted. So that means the power have been multiplied, and then this one got divided.
X, Y, over Z?
X, Y, and Z, yes. Another thing too is this part here. Okay. So if you look at this piece over here, this is the same thing. I'm going to write it at the bottom so it's easier to see. This is the same thing as log of x squared base 3. Okay. So
those are just squares?
it's going to be squared. I'll show you in this form. So that's this one right there. So n is our 2 log of m. So if we were to write that down, it's going to be m to the n. Okay, m to the n. And then if you think about that in terms of exponent laws, when you have power to a power, we multiply the exponent, right? Now what about this part? It becomes log of y to the 4th base 3. Oh, sorry, you can't see that. Log y to the 4th base 3. And then this one, it's just going to be minus log z base 3. So these 3 different logarithms, they all have the same basis. They all have the same basis. Now these two are being added. So that means the powers got multiplied. So this becomes log x squared y 4th, and then log z base 3 got subtracted, so that's divided. So if you were to write that as a single logarithm expression, it's log of x squared y to the 4th over z base 3 with base 3.
And we can't combine the exponents because we don't know what x and y are just yet?
Yeah, we don't know what the x, they're not the same base, or within this, the x and y are not the same, so we can't combine those two.
Okay.
Okay, so now let's see. Here, there's nothing written, natural log, so that means it's operating as base e. What's happening here? Let's start with this 2 first. So this is the same thing as natural log of x minus 4 minus natural log of x plus 5 to the exponent 2. Okay, so if these two are subtracted, the two exponents are subtracted, then that means the power having the same base e are being multiplied. So natural log of x minus 4 over x plus 5 squared. And then that's base e. Understood, it's base e there. Is that okay? So those are a few examples of the expanded version, making it as one single. And that's possible because the bases were all operating in the same base. Same bases. Let's take a look at this one. If this is positive 5, then that would be x plus 5 over x plus 5 squared. Then that would cancel there. Oh no, not 1/2. It's going to be 1 over. Okay, so this is the question that was asked. Okay, let me see if I understood the question. You said if you went like this, if the question like it's x minus x plus 5 minus 2 natural log of x plus 5 base e, basically. If these were the same, yeah, okay, so that it would look like this. Okay, so this one would still be up there, right? That's still, it's going to be squared. And then because this is being subtracted, and it's natural log of x plus 5 over x plus 5 squared, yeah? And then the x plus 5 would cancel one of that. Would be was that the question? Yeah? Oh no. Okay, that's good. Any other questions? So that one is making us one single, this one expanding. So the reason why we're doing this is because there would be times when where we're going to expand. There would be times when we're going to write it as a simple single expression. Okay, so what's happening in here? Oh, what do you see here? It's being multiplied. X cubed y is being multiplied. So that means we're going to add them, right? So log of x cubed base 5 plus log of y base 5.
Would we write it as 3 log base 5x?
Yes, we will. I'm not quite done. Yeah, sorry. Yeah, so that's just splitting it up, right? And then here, exponent x, the 3 here will become 3 log of x base 5 plus log of y base 5. Yes? Yeah. So I like to show my work so that I'm not missing anything. And of course, if you see it that way right away, then yeah, go ahead and do that. Just I didn't want to miss something. Okay, so now here, the power x cubed over y. Okay, it's being divided, so that means it's going to be subtracted. So log x cubed base 4 minus log y base 4. And then the 3 can go at the front, so 3 log x base 4 minus log y base 4. And that's how far we're going to go with that one. Okay. Any questions so far?
For A, that's the power law?
Are you talking about this one? The letter C?
No, like letter A.
This one?
Yeah.
Product law.
Product law.
Yeah, product law.
And
Because you're
then
multiplying.
quotient?
Yeah, so this one here, using the product law.
And quotient for the next.
Yeah, so this one here, if you're looking at the exponent rules, it's going to be quotient rule. It's quotient law.
What's the last law?
Oh, and then this one here is a power law.
Power law.
Yeah,
There.
so it's a power to power.
So when it moves over
Mm-hmm.
power law.
Where you multiply the exponents. So this is an exponent, and then you multiply the other exponent. Okay, now let's take a look at this. Now, I see there's a square root introduced in here. So let's break it apart. Natural log. Now, square root means the exponent there is to the exponent 1/2. So this is going to be a times b to the 4th to the 1/2. That's what square root is about. Okay, we kind of discussed that at the very beginning of this chapter. The square root is exponent 1/2. Now, if we apply into that, so this becomes natural log of a to the 1/2, b to the 4 times 1/2 is b squared. These powers are being multiplied, so we're going to add natural log of a to the 1/2 plus natural log of b squared. So this becomes 1/2 natural log of a plus 2 times natural log of b.
Do you have to bracket it?
No, I just did that. Yeah. Okay. I'll give you an alternate, a different one, okay? There's other way. Just in case you come across something that is like, hey, I didn't know that this is possible too, okay? Here's the other way. So far it's going to be natural log of a b to the 4th to the 1/2, right? So what can we do? That exponent 1/2, we can say that, hey, that's 1/2. 1/2 times the natural log of a times b to the 4th. Okay, here's the other way. Now, so the 1/2 is already outside. Now let's deal with the inside. This becomes natural log of a plus natural log of b to the 4th. So this one here is just 1/2 natural log of a plus 4 times natural log of b. So it's the same approach, and then you multiply it in, you're going to get the same thing. if you multiply the 1/2 in, you're going to get 1/2 natural log of A plus 2 natural log of B. Take a look at example number 2, letter D. Now this is a cube root, so that means 36x to the power of a third over y squared. What can we do? So being divided, oh, I forgot the base 6 there. I gotta write base 6. So it's gonna be log of 36x to the 1/3. Now, it's important that I have to put a brackets around the 36x because that 1/3 applies to all of them. With base 6 minus log of y squared. So the next piece is to bring out the 1/3. So 1/3 log 36x base 6 minus 2 log y base 6. Can we split this up a bit more? Oh, no. Sorry, I already took that out. So this 1/3 is for that piece. Can I still split this up? Yeah, we could, because 36 times x, okay, so we can say it's going to be 1/3 log 36 base 6 plus, yes, keep going, log x base 6 minus 2 log y base 6. Okay, now I can probably clean this up a bit, right? You see how crazy it could get? What can I do? Okay, I can apply the 1/3 to every single one here. So this is going to be 1/3 log 36 base 6 plus 1/3 log x base 6 minus 2 log y base 6. Okay, so 1/3 is just 1/3. Can we figure this out? Log of 36 base 6. What would that be? Okay. What exponent do I have to apply to 6 to get a 36? 2, right? 2. I'm going to write that down. Log 6, this is going to be 6 squared, yes? Plus 1/3 log of x base 6 minus 2 log y base 6. So it's saying that, hey, I need to have exponent 2 for 6 to make 36. So it's going to be 1/3 times 2 plus 1/3 log of x minus 2 log y base 6. Yes. And I just multiply that, so that's going to be just 2/3. So to fully expand it. I gotta get back in here and just make sure that I didn't forget the base 6. Otherwise, there's going to be deduction for me there. Okay. Maintaining the base 6 throughout.
Do you have more examples like this one?
We will have some examples, some practice questions for sure in the book. Okay, good. Let's take a look at this part here. What does it say? It says here, use the logarithms to evaluate. To evaluate. See if we can evaluate this. Now, if I go over here, let's cover that piece. I'm going to cover that piece. What's the question that what does this really mean? What exponent do I need for 4 to get an 8? No, it's for base 2, right? It's hard, right? It's going to be like 1 point something, 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 right? So this is hard. Here. 4 to what exponent will give me 32? 4, okay, so that alone, so 4, let's say 4 squared, that's going to be 16, right? But if I go 4 cubed, it's going to be 64. No, but this is base 4.
Yeah, but can you
Yeah.
just like make it so?
Can you switch the bases?
Yeah,
Like make them both base 2?
because you could do.
We don't, yeah, right now we haven't done the change of base stuff yet. Okay, so, but if I change the base to 2 there, that might, it's going to change the whole expression. So here's what we're going to do. How can we use the logarithm rules to evaluate this? So here we go. What do I do? Okay. We're gonna, yeah. Yeah. Challenging, right? So how can we use the laws of logarithm? So they're split up right now, being added. So what do I need to do? How can I write it as a single logarithm? Log of 8 times 32 base 4. Yes? Right? So 8 times 32 is going to be 256. So log of 256 base 4. So now let's see here. When you say evaluate, find a value. Okay? What's the value of this? Now, what's the question that we're thinking about? I got a base 4. What exponent do I need to get a 256? 4, right? Because 4 to the power 4 is going to give us 256. So 4. Okay. Now, here's the other thing that I could write. Actually, I'm going to erase this and I'm going to show you. It's 4. So log of 256 can be written as 4 to the 4th, right? So what exponent do I need for 4 to get 4 to the 4th? The answer is 4. Yes? 4 fours, yeah, 4. Yeah. Didn't really think about that. Now, what about this one? Log of, oh, this one's easy. What exponent do I need? 9 raised 2 to get an 81. becomes 2. Okay, here's the more convoluted way, because it says here I have to use the laws of logarithm. I didn't really use a lot of logarithm rules to figure that out, because that's just pretty simple, right? But here's what it is. Log of 81 base 9. So that's the same thing as log of 81. How can we write that as the same base? It's going to be 9 squared, right? So 9, the exponent is 2. If you want another funny thing is, yeah, well, here's another way. Expand it even more. Using this, the exponent is 2, right? I can say, hey, this is 2, it's going to be log of 9 base 9. Well, log of 9 base 9, just go back on our notes in here. This is something. Log of a base a is 1. So log of a base a is equals to 1. So this is going to be 2 times 1, which is 2. Okay. So far, so good. Let's see if we could figure this out. So all of these are base 2, which is nice. I see that it's going to be 2 log 12 base 2 minus all of that. Okay, so what can we do? What log rule can we apply to the first one? It's going to be log of 12 squared base 2, right? Let's do the 2, we'll go over there, so that's 12 squared. Minus log of 6 base 2 plus, what rule can I apply in here? It's going to be log of 27 to the power of 1/3 base 2. Any questions to that one? So I'm putting the exponent up there.
So when we have something like this, would it be better to combine the additions?
Yeah. Oh, this one here, I see that the brackets are indicating that this is together. So mine, whatever this is, we're subtracting all of that. Yeah. We were going to combine these two as well. So let's see if we could. It kind of follows the orders of operation as well, just like what we normally do. So log of 12 squared, so that's going to be 144 base 2 minus, how can we simplify these two? This is going to be log 6 base 2 plus, what's 27 to a third? 27, that's the same thing as cube root of 27, which is 3. Yes? 27 to 1/3, it's the same thing as cube root of 27, which is 3. Now what are we going to do here? I see that these two got added, so I can go log of 144 base 2 minus log of 6 times 3, which is 18 base 2. I'm going to go over here. Now, these two are getting subtracted, so that means we have to do the division. So log of 144 divided by 18 base 2. It's going to give us log of 8 base 2. Okay, now this one's probably super easy now. What's log of 8 base 2? 4? 3. Has to be 3. 2 to what exponent will give us 8? It's 3. Okay.
We're not going to write it out like the log of 2 to the 2 to the 3.
Yeah, you can. You can do that. You can say log of 2 cubed base 2. That's the same thing as 3 times log of 2 to the 2, which is 3 times 1, which is 3. Are we still on the screen? Yeah, you can go further this way to get the 3, same answer, or you can go here. This is pretty simple enough to get the 3.
Do we do any logarithm without our calculator on the exam?
Then there might be some questions that are just, say, no, evaluate. Part of the provincial exam is with a calculator for a certain X amount of minutes, and then after that, it's calculator free.
So if we're doing how complex?
Oh, like this one shouldn't be as complex. This one you could do it
Yeah.
without, right?
No, about it was like really weird.
Oh, like really weird. It would say you're allowed calculator for this question.
So is the first part where we get the calculator and then a calculator?
Yeah, the first part would be with calculator, and then the second part would be no calculator.
Is it like half-half?
No. Most no calculator.
So we're just more using simple numbers.
Yeah, it would be
Or-
simple numbers. It wouldn't be like ridiculous big numbers, right? It's going to be simple enough to do it without calculator. Yeah, oh yeah, it will. We'll get to that one. Any decimal? There might be. It may be very simple. Like maybe if it's a fraction, it's a simple fraction. Nothing. Yeah, we're not testing the calculation. Can you do those things? Like it's actually the base, like understanding the math behind it.
So if you get your calculation wrong, but you got your math right?
Yeah, part marks. Okay, it says here, is this why you're asking like without calculator? So it says here, use laws of logarithm to evaluate the following without calculator. So some calculators have like great capabilities of solving stuff and then, rationalizing the denominator, which you're not gonna have access to that one anymore. Okay. Okay, let's do this one.
But it's also nice to have that to like double check,
Yeah,
you know?
the
And then
reasonableness.
it's like taking away a safety net and then being like, okay, tightrope walk now.
Yeah. I know. Okay, is it okay if we move on?
Quick
Okay.
break?
Huh?
Quick break?
Want a quick break? Okay. We could do a quick break and then we're gonna do example 4 and continue on, and yeah.